just gonna brush it down. I personally try and clean every chip I make on this machine. I try and clean it off. So, just for like longevity, because it doesn't have any way covers or anything. So.
Right. So definitely clean the ways.
Yeah, at the very
chips out of
least. This is less essential. And I guess the table, like the top of the table is important, but yeah, clean the waves. And the launcher is this Penguin G7, no homing. And then make sure this is clicked on. That, you know, connects, turns on the power of the machine. So once you're here, it's like automatically defaults to locked mode, so you can't do anything. So if you take off that emergency stop and then hit that, now you can use the arrow keys to move the table, and you can use page up, page down to move the head.
Cool.
Alright. So one good thing to know that I figured out, whoever used this last definitely figured it out too. If you're trying to use this vise, you kind of want to, like, I always put it back on this rail right here. Because if you mount it to the middle rail, it like sticks out and then it like limits your Y travel by like 3/4 of an inch or maybe even like a full inch. It's pretty limiting for me. So for homing, I do the Y table as far back as it can go. And for this, I like to home each axis at a time, but if you want, you can do it all at the same time. I don't know. So like here, you can choose the specific axes you want to home. So I'm gonna hit home Y. Now it goes back, but it won't crash into the thing. But there are no limits on it, so if like, it'll go and run into this.
Okay.
If you keep going, so like, that's as much as I would ever really go, maybe like there. So just be like, check your program before you run it, go to like the most negative or positive Y value and like make sure it doesn't crash into this.
Okay.
Just something to know, it doesn't have a limit that'll like stop it from crashing into that.
So you homed it as close to here as you want to get, but there's not actually a limit. You could blow past that.
Well, it'll stop going this way, because like the machine or the computer knows not to go past home, but there's no limit. There's no hit the other way.
Okay, so you can't have a negative value after you've set the home.
Yeah, correct.
Got it.
That'll be the X home. And then I don't always go to the very top of this because it's kind of slow. I don't want it to go all the way to the top after every thing.
Right.
So I'll just do it right there. Tighten those down.
Okay, so we got our spoil board here. Always using a spoil board so we don't gouge the table.
No milling into the table.
Yes. And we're just wiping down the surfaces of the part in the spoil board with alcohol to get them nice and clean, and then we're going to use double-sided tape to stick the part down. So we're just pressing the CNC tape down into the part, trying to get it to stick real well. Seem pretty solid?
Yep, that looks really good to me.
Cool.
Sweet.
Okay, so all the bits are over here. We got collets underneath the machine.
Also got all the other tools like the drill chuck, various wrenches, and to load the tool, push it up here, make sure it's found that slot, and then tighten this guy. Once you've gotten it tightened, there's a hole right here. Take this guy and this small guy. Just hand tighten. Don't go crazy. This is how you start the machine.
Okay, so the LinuxCNC doesn't control the spindle speed?
It does
it's
not.
All manual?
Yes. So about 2000 RPM is good for milling, I think, with that bit. Basically the only ones I ever use is on, off, spindle speed, and then
Forward, reverse.
that's forward, reverse, forward, neutral, reverse. That's high and low speed. There's 50, 100, 1125, 2025. So that just designates like if you're in low or high, low or high. I just keep it in high at all times because I'm never gonna go below 1500 RPM cutting this really. So.
Okay. Looks like we have a Z lock here, which we want to keep loose,
Yep.
obviously.
Yep. So to extend the head, there are two locks. This locks the head down, so undo that. This locks the handle, so undo that. And then I'll move it down, I don't know, an inch. Lock the handle. And lock the head.
Okay.
Cool. So then we'll load in the file. There we have. Okay. Yeah, when I make that slap on part, I have like a plate and I zero onto the left corner. I just want to drill one of these pockets right here. So let's see.
Okay, so we touched off and now moving to where the pocket is. We'll see how that lines up on the part.
Now, move all the way down, basically there. Really close. And then I change it to 1 thou increments. And then I just keep going down until it stops the paper from moving. So, once it completely stops moving, that's usually where I touch off. Cool. This gCode with a feed rate of 10 inches per minute. It's really slow. And I'm going to go ahead and go to the feed override. I'm gonna run it at like, I'm gonna run it at 50%. So it's really going at 5 inches per minute. Because like this machine is not the most stable. If you go faster, it just like it's gonna have not that good of a time.
Yeah. And we sprayed some WD-40 on here.
Yep, so there's some WD-40 right there, which is totally fine for cutting aluminum. But anything else, probably use an actual cutting fluid. Anything that actually gets like hot when you cut it, I wouldn't use WD-40. Okay. So it is going to go to this one first. I'm going to go ahead and turn on the spindle. And I guess it's worth saying that like I've ran this program a bunch of times, so I know it's not going to crash straight down. Any program you run first, it's like good practice to maybe like put the rapid and the feed like way down and kind of like pause through to make sure it's not going to crash into the part or whatever. Just something to think about. Because it'll get really close going down, it's kind of scary. And then it'll slowly spiral into the through.
So do you use Fusion for your toolpaths?
Yep.
Do you have you just use the stock LinuxCNC post-processor?
Yep.
Do you have to make any manual tweaks to your gCode after you export?
I usually don't. I mean, you can go in and like get rid of all like the spindle speed stuff and like the spindle stop and everything because I control it, but it doesn't make a difference because it just goes through it anyway. The main thing I do is, I mean, Fusion 360 defaults to like really fast key breaks, so I make sure that like every pass is like slow. And you can either sit here with a vacuum, or I just like to occasionally brush all the tips off. And I'm taking like, I couldn't tell you like the exact depth of cut, but this is 1/4 inch plate and it does about 9 passes. So pretty thin. This rule, if you don't want to cut too heavy on this, I don't know if you, so like on that mill, you could probably cut like 0.1 inch deep and like it would be fine. This, I would not go that deep. I would go like, I don't know, like 15 thou depth of cut at most. There aren't as many safety features on this one, so like safety's kind of in your own hand. So it didn't go all the way through because in my actual gCode it's accounting for the faced plates. It's a little less length, but yeah, it went down 0.2 inches.
Right on.
There we go. If you're cutting
Cool.
slots, like if you're milling a slot, run it really, like much slower than I just did right there.
Because it's full width cut.
Yep, full width cut, and this isn't the most stable machine. I mean, like the whole thing moves around, right? Like
Yeah,
so,
it's pretty spindly.
yeah, I've cut a few slots, and like I just have to run it really slow, but it can handle it, you know. That's basically it.
Okay, so just do a really thorough cleanup, get all the chips out of the ways.
Yep, I like to brush all the chips off the table and the ways, and then vacuum them up.
Cool.